Hi, this is Nitaigour Mohalik, your instructor. This module's topic is logic processing hardware, which includes microcontrollers, PLC, Fieldbus technology, and SCADA systems. So, PLC stands for Programmable Logic Controller, and SCADA stands for Supervisory Control and Data Acquisition Systems. The goal of this short video is to introduce these four technology platforms, and the detailed explanation and information about these can be found at study materials link in this module. The learning objective of this topic is to know what these technology platforms are and where they can be applied as far as automation is concerned. The processing hardware for main logic system can be categorized under four categories. The top one is relays, logic gates. Those are usually not used. Long time ago they were used for implementation of the control actions. Then microprocessors and microcontroller came, and again PLC computers, desktop PCs, powerful computers are also being used in order to control the plants. And finally, the fieldbus technology and supervisory control and data acquisition are the recent developments. Right hand side, all the images that you see, those are the the applications like military, automobiles, industrial control, robotics, chemical industries, food processing industries, medical devices, appliances, home appliances, like that. We need microcontrollers, PLCs, or fieldbus systems or SCADA systems in order to implement the control actions, and those are called processing hardware for main logic. What you see here in this image, it's actually the inside of the CPU, central processing unit. You don't have to remember anything here, just to take a look that okay, within the CPU there are many building blocks, and I have listed all those building blocks right hand side. So it includes accumulator, it includes temporary register, arithmetic and logic unit, instruction decoder. So these are, and also temporary memories inside the CPU. So these are required, and they have been connected in such a way that everything flow works. Flow, what I mean by flow is that whenever you write code, then this CPU must execute those codes, okay, based on your program. So they have been designed. You don't have to think how they have been designed, but just to have a kind of little knowledge about what are inside. So since this is a micro lecture, so I don't want to explain right now. So if you would like to dig into what those components are, what those building blocks are, you can uh, do. And I have posted all those information in there. So the last slide was the CPU, and this slide is the microcontroller. As I have mentioned that within the microcontroller you have additional building blocks such as PWM, analog to digital converter, digital to analog converter, and also the IO port, interrupt controller. And on the top of 12 basic building blocks that are that should be there in the CPU, this microcontroller has additional building blocks which are required in order to implement control systems. So this microcontroller is known as 8XC196KC microcontroller from Intel Corporation. It is a 16-bit microcontroller, very popular. Most of the appliances, they use this kind of microcontroller. If you need any microcontroller in future for your application, so I suggest you use this one. This is really a good one. This is a PLC. PLC stands for Programmable Logic Controllers. It's not a microcontroller, rather a PLC. And the meaning of PLC is that it has, CPU also inside, and also memory, output modules, and input modules. What it has inside, actually lots of relays. Relays are nothing but the switches. If you go back to our fundamental theory, that any logic you can implement using the switches. Okay, that's important to know. So all the logics, any kind of logic, for example, what is the meaning of logic? Logic means if, when, then do something. If this occurred, then do something. When this happens, then do something. So this is a kind of logic. All the automated systems play game around logics, small logics, large logics, all the larger logics can be segmented or divided into smaller logics. So all your programs actually, they are logics. Based on the logic, you are developing the program and writing the code, and the controller executes all those logics, you know embedded into the program. So everything that, if you think about logic, then it's nothing but kind of switches composed of lots of switches, on and off, on and off. So these controllers, they have internal architecture, hardware. They can execute all those kind of on and off things, in a very sequential and a logical manner. Okay, that's why all the PLCs or microcontrollers, they have inside kind of simple binary systems or digital systems, but it's digital, on and off, 0 and 1. Okay, so we have already studied all those things. So a programmable logic controller is an industrial digital computer used to automate manufacturing processes, machineries, and systems. It Let me talk about the Fieldbus technology. A Fieldbus technology is actually a control networking system using which you can implement a distributed control. What is the meaning of distributed control? It's not centralized control, meaning that all the microcontrollers, they are connected into network. So here, what you see in this application, this is a packaging line application. It has a robot, it has conveyor belt, and it has a motor. So all, and also sensors. All these sensors and motors are called actuators. Sensors and actuators are connected into a network, single network, and it's called Fieldbus. And what you see here, N1, N2, N3, N4, N5, these are actually the microcontroller. They are connected to sensors, and other end it is connected to network. So the difference between the centralized system and the distributed system is that you have here only one networking system instead of a one-to-one wiring. So you can save the cost. So distributed control system has many flexibility. You can program one node and then replace another node, so while the other node is working, so like that. So it has flexibility. Thus, SCADA technology includes SCADA software, SCADA hardware, SCADA interfacing. SCADA software includes operating system, graphical user interface, human machine interface applications, and also coding applications. SCADA hardware includes microcontrollers, PLCs, computers, cyber security systems, and memory. SCADA interfacings are wireless, all types of communication standards, fibers, cables, traditional cables. And the important thing is that they follow, whoever develops SCADA technology, they follow international standards like Open System Interconnection, OSI. It's a kind of standard, open system standards. And there are organizations, international standard organizations, they standardize everything, all aspects of interfacings. And the technology developer, they follow the guidelines of the standards, international standards, as far as communication is concerned. Okay,